I'm going to show you now how to do a regular chi-square test by hand. So this is if your table is going to be like for example, a 3 by 2 or a 2 by 3 or a 3 by 4 or a 3 by 5, that kind of thing. So if if your table is a 2 by 2, then stop watching this video. You need to go and watch the other video I've got, which is a chi-squared for a 2 by 2, because that's a completely different process. So what we're going to do is now do one for a 2 by 3. So select your data. Again, my data is just GDP per capita, CO2, and make a new sheet. Control V, and now I'll call this one, we'll rename it chi-square 1, and save it. So what we've got to do now is because I'm going to do a 2 by 3, one of my categories has to split into 1 and 2, like high and low, and I need to split my other category into high, medium, and low, because it's going to be a 2 by 3. So I could split this one into high, medium, low, and then to high and low, or vice versa. So it's just pretty random. So I'm going to split this one into high and low, and I'm going to split this one into high, medium, and low. And that's just because I just made that decision just now. So what you might want to do is maybe work out either the average or the middle version of each one. That might be a good idea. And then you can use that to kind of make some kind of estimate about what your categories are going to be, like what your boundaries are for high, medium, and low. So let's go equals MED. You could do average as well, but I'm going to do median in this case. So median, we'll do the median of my x's. Close brackets, enter. And that's my median x, so maybe I want to type that in here. And now I'm going to do my median y. So equals MED, double click on median, and now select the numbers in the y. Go down, select, close brackets, enter. So I'm going to use that to work out how I'm going to break up my GDP into high, medium, and low, and my CO2 into high and low. So GDP per capita. So I've got to have low GDP, and I've got to have medium GDP, and maybe I'll just scroll that across a bit, and I've got to have high GDP. And my other category, CO2, is the one I said randomly I'll split that into 2. So I'm going to have low CO2 and high CO2. So it's pretty easy maybe to work out how I'm going to split up my CO2, because looking at this, 2.5 is the median. So maybe I might split it into low CO2 is 0 to 2.5 roughly. This is just a rough approximation. It's up to you how you break it up. And my high CO2, maybe I'll just say is above 2.5. And that could be my boundaries for now. Looking at this, I've just got to make a weird educated guess, because I'm going to split this into 3. So I just want to make that nice and even. So let's see, 8,000 is a median. So maybe I could say like something just at a rough guess, 0 to, what could we say? Maybe 0 to 5,000 could be low. Medium could be 5,000 to maybe 10,000. No, sorry, yeah, 10,000. So I need to make that a bit wider so it fits. 5,000 to 10,000, and then high would be above 10,000. This is just me completely making this up right now on the spot. And now what we've got to do is we've got to use these boundaries to categorize each group. So looking at this, 962, that's low GDP, but 0.03, that's also low CO2. So this is an example of a low-low. So maybe I want to do that. I'll do GDP is the first letter and CO2 is the second letter. Let's see, 5305, that's medium GDP. And 0.9, looking at my boundaries, that's high. No, that's not, it's low. CO2. 988 is in my medium still. Medium GDP, be careful because sometimes Excel tries to type in a letter for you. 2.87 that is, looking at my CO2, that's above 2.5, so that's high. So I've got medium high here. And this takes a while, but you've got to go through and do this for the whole like list that you've got. 3387, let's see, that's low GDP per capita. Just make sure it's not trying to predict it for you. 0.68, that's low CO2 according to my table. 19,000, that's above 10,000, so that's high GDP per capita. And 4.4, that's also high CO2. So I've got high here. And you've got to go through and do this for your whole table. So this is high GDP per capita. And 3.81 is also high CO2. 2,000, that's low GDP per capita. And 1.1, that's also low. 43,000, that's high GDP per capita. 24 is also high. And so on. And so I'll pause this now and I'll fill in the rest of the table. And then, because you don't need to sit and watch me do this, but you'll have to do your whole list for your table. So now we've jumped ahead in the future and I've actually filled this all in. So it's quite painstaking. It takes maybe 10 or so minutes of your time. Make sure to save it because you don't want to do it again. So see, I've got a mixture of medium lows, like high highs, low lows, high lows, medium lows, low mediums, that kind of thing. Actually, there's no mediums because on the second one, because it's all high low for the second one, and it's medium low high for the first one. Now we've got to make a little table. So we've got to make our little summary table. So this is how many you've got of each. So that's an example. This would be my low, medium, high, and low and high will go here. So I'm going to set this up, this little table. So here I'm going to have low, maybe make it like this. I might say, so I'll do GDP first, because GDP is my first column. Low GDP, then I've also got medium GDP, and I've got high GDP. And up here I've got low CO2, and I've got high CO2 because I don't have low, medium, high for that. Now I've got to work out all the values that fit in here. So maybe you'll make some nice little grid lines because I'm going to make a table or borders. I'm going to fill in my frequencies, just kind of like how they did there. We're going to do that now. So we've got to, rather than just go through, okay, so high, rather than go through and count all the high highs, that's horrible. There's a great thing you can do which is called sort and filter. So click on column C, so actually click up in the C and then select it. So now notice it's all selected. Then go to sort and filter, sort A to Z, and make sure that expand the selections ticked because that's important. Click OK. So what's awesome is that these all match up with high. So notice that it's completely changed. That's how it was before. And now it's all sorted. All my high highs are together. So a quick way to count them rather than go through and count them, which is horrible. Just click on it and scroll down to the bottom of the high highs. And down here it tells you, count 19. So high, we've got 19. Let's type that in there. That's done. High, low, there's only 3 of them. So, and what that means, it's high GDP, low CO2. So high GDP, low CO2 is here. So I've got to type in 3 because there's 3 entries there. Low, high, there's only 2 of them. So that's low GDP, high CO2. Low, high is here. So I've got the number 2 there. What else we got? We've got low lows. There's a lot of low lows. So you can see low lows, we've got 15 of them. Counting by hand can be a bit of a drag, so doing this is quite good. And that's low low, so just low low is easy. It's just there. 15. So I've still got to fill in the last 2. Medium high. Medium high, there's 4 of them. So that's medium GDP, high CO2, medium high, 4. And now, how many medium lows do we have? We have, let's count them down here. Medium low, we have 7. Now you want to check that these all add up to however many rows you've got. So just click on here. So I've got, let's count, 50 countries. So my numbers need to all add up to 50. So let's see, 15 plus 7 plus 3 is 25, plus 2 is 27, plus that is 31, and 31 plus 19 is 50. So it's good. I've got 50. That's what I need to have. So these little things, they're called your observed frequencies. So let's maybe make them bold and red because they're important. To do the calculation in the tables, eventually you're going to need the totals of each row and column. So let's do those now, and we won't make those red. We'll just keep them a regular color. So 15 plus 7 plus 3, it's actually 25 in my case. 2 plus 4 plus 19 is also 25, just complete coincidence. It turned out to be the same number. 15 plus 2, 17. And notice 25 adds to 50. 7 plus 4 is 11. And 3 plus 19 is 22. So double check that. 22 plus 11 is 33. 33 plus 17 is 50. So that's good. Our total works out. And now we've got to make this big table here. So this is the big table we've got to make. So we might want to take a snip of what we've got here. So let's take a little snip of these headings. So excuse me, so we can paste them into here. Control V. That's a bit big. Maybe you can shrink it down a bit. We can also see we can kind of make that a bit wider as well. So let's try to fit that in there. I need to maybe scroll these across so that they match up. And also make that a bit less looking weird. So let's make that match up. And so on. Takes a little while. Almost there. Great. And actually mine's a little bit too squished up, so I'm going to stretch it out a bit again. That looks a bit too squished up. Okay, that's a bit clearer now. Now again, let's say what we're doing. We need to make a table. So we're going to have to put all these categories in here. So hopefully, yes, it's all going to fit good. So I'm going to put maybe low first. So low. So my observed frequency for low is 15. You can see from there. Then I'm going to do medium low, ML. My observed frequency for medium low was 7. Then I'm going to do high low. So high GDP, low CO2. My observed frequency was 3. Now we've got to do low high. So low high LH. Observed frequency is 2. And let's see, medium high, so MH. Just make sure you don't double them up by mistake. Medium high is 4. And the last one is high. Excuse me, sorry. High is 19. That's it. Again, that was a lot of work, so let's save that. That's called your observed frequencies. They just come from your table. Now what we've got to do is calculate the things called the expected frequencies, and that's what these totals were for. So because the way you calculate the expected frequency for low, you go to the cell and you take its column total or its row total and you multiply it by its column total. So multiply these two and divide by the total. So let's type that in here, equals low and low, its row total is 17, multiplied by, use the star. Low, it's got a column total of 25. Then divide by your total. In my case, I've got 50 countries, but yours might not be 50. Then medium low is this one here. Its row total is 11, multiplied by its column total, which is 25, divide by total. Next one, high low, so its row total is 22, multiplied by its column total, which is 25, divided by total, in my case is 50. Low high equals, low high is this one, row total is 17, multiplied by column total, which turned out to also be 25, just coincidence, divide by total, which is 50, so on. Medium high, its row total is 11, multiplied by column total, 25, divide by total, done. And next one, last one, equals high. I've got a row total of 22, multiplied by the column total of 25, divide by total, which is 50. Lovely. So what's really important is at this point you have to kind of pause and look and decide, is your chi-square test going to be valid? Before you bother to do all this part, let's see, is a chi-square test going to be valid? So according to, if it's not a 2 by 2, like if it's a 2 by 3 or if it's a 3 by 3 or so on, then what the case is that you're allowed to have 20% of these are allowed to be below 5. They all have to be above 0, so none of these are allowed to be 0. That's definitely the case. If any of these are 0, then your chi-squared test is invalid and you have to go back and readjust your boundaries and start again so that it won't come out as invalid. If you've got a 2 by 3, like let's see, so only 1/5 of these, like 20%, which is 1/5, only 1/5 of these is allowed to be below 5. So notice all of mine are above 5, so I'm okay. But if I had one of them below 5, that would be okay, because that's 1 in 6, and 1/6 is less than 1/5. Like if you do 1 divided by 6, the number's less than 1 divided by 5, less than 20%. But if I had 2 of them, then 2 over 6 is like a third. That means 33% are less than 5. Then my chi-square test would be invalid. So if you've got kind of 6 rows here, only one of these are allowed to be below 5. And if that's the case, your chi-square test is still valid. If 2 of them or more are below 5, then it's a boo-boo. You've got to go back and readjust these boundaries and then go and redo this again and this again, and then hope that when you put in your new totals that it's not going to come out as being any different. I mean, like it's not going to come out as being having more than one below 5. So I'm okay because all of these are above 5, so I can proceed. The rest of the part's pretty easy. So notice it's FO minus FE. It's my observed frequencies minus my expected. And we can just use Excel formulas. So go equals, click on your FO, type in minus FE, enter. Then click on the cell and scroll down. And that's done. What we now need to do as well is we've got to square that. So we've got to take this value and we've got to square it. So go equals, click on that value, and to square it you do arrow upwards 2. That makes squared. This makes sense. That number squared is that. That number squared will be, let's see, these numbers. So these numbers all squared become that. And my last step is I've got to take that previous cell and divide by my FE. So we can do that easily. So equals previous cell. Oops, I clicked on the wrong thing. So back here, let's delete it and start again. Equals previous cell, divide by, so forward slash to do divide, FE. Click on your FE, enter. We're almost there. So we're so close. Let's quickly save what we've done. To actually get your chi-squared value, you've just got to work out the total of this last column. So to do the totals in Excel, remember you go equals sum. Double click on sum and select the numbers. Oops, something was wrong there. And then select my numbers. Oops, something's gone wrong, so I'm just going to start again. I don't know what went wrong there. Equals SUM, double click and select my numbers. Close the brackets, enter. And that's a really important number because that's my chi-squared number. So let's make it bold and let's maybe put some grid lines on our table because we're going to eventually paste that into Word. So put some grid lines on there, put some grid lines on this one. Maybe here say that it's a chi-squared value. Is that? We can do that. Oops. Okay, let's just type it in, chi-squared value. Chi-squared value. So a chi-squared value is 22 point something, and we've now got to decide, does that tell us whether our GDP and CO2 are dependent or independent? So we've got to compare it to a thing called the critical values. So you might remember in your test you're always given the critical value, but here you have to work it out yourself. So my table is a 2 by 3, and I just realized, whoops, I'm looking at the wrong one. So my table, I know this is the right one, my table is a 2 by 3 kind of thing. So it's the because I've got 2 columns and 3 rows. Actually, technically it's a 3 by 2, sorry, because it goes rows and columns. And I've got 3 rows and then 2 columns. So, but it doesn't matter, we can still calculate our degrees of freedom. So degrees of freedom equals, like, it's going to be, because I've got 3 rows, 3 minus 1, remember row minus 1, columns minus 1, bracket time multiplied by, I've got 2 columns, 2 minus 1. And I can just tell by looking at that, 3 minus 1 is 2, 2 minus 1 is 1, 2 times 1 is 2. So I've got 2 degrees of freedom. You've got to choose a significance level. You can choose either 10, 5 or 1. It's totally up to you. So I'm going to choose a 5% significance level this time, just randomly. So maybe record that here. 5% significance level. You choose 1 or 10, it's fine. So now we're going to look at what the critical value is. So for degrees of freedom 2, 5% significance level. In my case, my critical value is 5.9, because see, degrees of freedom 2, 5%, so 5.99, I should record that. So critical value equals 5.99 in my case. So I've got to decide now, is my calculated value higher or lower than the critical value? So as the calculated value is greater than the critical value, try to remember what the outcome was. If your calculated value is higher than the critical, the 2 variables are dependent. Then GDP per capita and CO2 per capita are dependent. If it turned out that this value was less than the critical value, then it would turn out they're independent. So my chi-squared result has kind of backed up my scattergram. If I look at my scattergram for this, GDP and CO2, that's a pretty good correlation. I can even check with my Pearson one. Got a reasonably strong to moderate to strong correlation there. I'd say probably more moderate, but still. That's probably why it's coming out as dependent. But sometimes they can contradict each other, so it doesn't really matter. You've just got to comment on that, and so on. So just looking back on here, we were here. Chi-square 1. So that's the outcome. So you've got to make this table, you've got to copy and paste it into your IA, and so on, and you've got to also talk about this more in sentences. It's good to have it written down here, just so when you look back, you've got some results there in case something goes wrong with your Word document. But and otherwise, if people just have a number there, they sometimes look back on it in a month's time and have no idea what it was about. So writing all this stuff is useful. But then you've got to write it up properly in your IA and turn into sentences and paragraphs and interpretations like that. And so that's how you do a regular chi-squared by hand. And then I would have to then go back and I would have to do the same thing for my GDP per capita and my carbon dioxide, and have to do this whole thing from scratch. And do it all again like that. I would have to make my table. I'd have to at least do this part and that part and make my table, but then I would have been allowed to just work out the chi-squared value on my GDC. That would have been okay. But it's just as easy to type it in here as well. So this is a good little spreadsheet to have. And that's pretty much it as far as I remember.